In this video, I'm going to go into a simple investigation on software debouncing for a button. I'm going to review the circuit that we have on the breadboard. First, we're taking the VCC and ground and we're putting it to these two rails. Pin number 1 is going to the first LED. Pin number 2 is going to the button, which is going to ground. And pin number 3 is going to another LED. These pins are indexed from 0, so this pin number 1 is 0 pin, and then the next one is 1 pin, and the next one is 2 pin. So pin number 0 actually is the first LED, pin number 1 is the button, and pin number 2 is the second LED. Let's jump straight into the programming for the software debouncing of the button. Go to Start, All Programs, Win AVR, Programmer's Notepad. Go into our LED on, open, and then main.c. Going to maximize this window, and I'm going to bring this down so we can see the programming a little bit more. The easiest way to explain what is going on with the microcontroller is to show you in a stream of ones and zeros. The way this circuit is set up, when you press the button, the stream is going to be zeros, and when you're not pressing the button, the stream is going to be 1. This is because the pin on the microcontroller that the button is connected to is pulled up high, and then the button goes through to ground. When the button is pressed, the pin reads the ground signal, which is a 0. A very simplistic view of this would be as follows. If I'm pressing the button, it's going to be a string of zeros, and then I'm going to release the button, and then I'm going to get ones. I'm going to press it. I'm going to get some ones and zeros because of the bouncing, and then I'm going to go back to not pressing. What we're going to try to do is pick up a few of these zeros or a few of these ones. We don't want to pick up a signal like this, ones and zeros. We don't want to pick up signals like this. So we want a good number of zeros to know that the button is pressed, and we want a good number of ones when the button is not pressed. In the programming, we're generally going to pick up the first good set of zeros. So we're going to set up what is called a counter, and it's going to count the number of zeros that it's gotten consecutively. Of course, the more of the same number, like the string of zeros, the more of them, the better. But if you try to count too high on this number, then your button may become unresponsive or sluggish. This counter I'm going to call the confidence level. It is my level of confidence of whether I think the button is an actual button press, and if the confidence level is low, it could possibly be a bouncing of the button, mechanical bouncing of the button. It's also important to understand the scale of what we're dealing with. When the button is pressed, you will get hundreds or thousands of zeros, and this could be a relatively short press of the button. The same goes for when we release the button. So let's start by setting up the variable. Two variables are going to be important here. I need to know the confidence level of the button being pressed and the confidence level of the button not being pressed. Let me get rid of the stuff that I just put in. Get rid of the space here. So the first variable will be an integer, and it's going to be called pressed confidence level. And that's going to equal 0 in the beginning. Then another integer, released confidence level, going to be 0. When we press the button, which is inside of this area here, we want to increase the confidence level. So I'm going to just type in pressed confidence level plus plus. And this is probably the first time you're seeing the plus plus. The plus plus just means that I'm adding 1 to the pressed confidence level variable. It's the same thing as saying the pressed confidence level is equal to itself plus 1. Okay, now I'm going to add the same thing to the button being not pressed, and that's going to be called the released confidence level. And I'm going to add to that. So if there's some bouncing going on, this pressed confidence level variable, or the released confidence level variable, if there's a lot of really quick bouncing, those numbers are going to be really low. If we have the button depressed and the bouncing is complete or over, then the pressed confidence level will be a high number. How high this number is, we don't really know yet. But we're going to be doing some trial and error, a little bit of trial and error, to see what comfort level we can achieve with this button. I'm going to start off by checking a relatively low number. If pressed confidence level is greater than, say, 200, then I'm going to process the information within this area here, which is the button pressed information. And only if it has the confidence level of over 200, I want this information to be executed, doing the toggling of the two LEDs. And we need to do the same thing with the released confidence level. And we do not wish to assign pressed equals 0 unless the released confidence level is relatively high. So let's put in the if-then statement here. Released confidence level is greater than 200. And I'm going to provide a block around this portion of it. And it's also important to know, I guess at this point, that we're only doing one instruction here. We don't really need this open and close brackets here, because this doesn't really need a block of code. It's only one line, so these actually are optional. But I like to put it in there anyway, just in case I put more lines of code in. Get rid of this line, and we are ready to program. There's one thing I forgot, and I have to set the pressed confidence level. Once it has achieved these instructions and it's complete, we need to set this pressed confidence level back down to 0. Pressed. So we can go ahead and do more button clicks, and it won't just work for one. Okay, we'll do the same thing with released. Now we're ready to program. Make sure the programmer is plugged into the breadboard correctly, and the programmer is plugged into the computer. And let's go ahead and go to Tools, Make All, see if we have any issues with errors. We do have an error. I probably misspelled it. Yes, I misspelled release, R-E-L. Okay, save that. Let's try it again. Yep. So it looks like we have an error-free program. Let's go to Tools and Program, Microcontroller. Okay, let's check out what we did, see if it worked. Alright, let's check it out and see what happens. So far, oh, I see a bounce there, so we didn't really take it out completely, so we're going to have to increase the confidence level and then reprogram. Okay, since we know that the 200 was too small a number, I'm going to just go with 500, and we'll change the other one. This is a bit of trial and error. You could essentially write a program to determine the average lengths of button presses, and then you can take a percentage of that and then find out that's actually would be the best way of finding out what would be perfect for your button. And we can go into that in greater detail later, but this is really just a quick software debouncing, and only one way of doing it. There's other ways you can debounce through software. You can use interrupts, which we haven't gotten into yet. We can have a timer interrupt. It'll interrupt the program flow on every, let's say, second or millisecond or 20 milliseconds or whatever, and it will allow us to check or pull the button during those moments, so it won't take up too much of our programming cycles. We'll get into that later when we get into interrupts. You could also introduce another type of delay like we had with our LEDs, but I really don't like to introduce delays into the program, as that takes up a lot of cycles of programming, and it doesn't really allow you to put anything inside those delays for, in terms of programming. Of course, as your program becomes much more complex, this 500 can actually be reduced because the time it'll take between adding the confidence level increments, they'll be farther apart because of further complex programming. So let's see what 500 does. When I was doing it before, I was using 1000, so I know 1000 works. Let's just go ahead and try the 500, see if I can get many button clicks without getting an issue with bouncing. Okay, so let's make all and then program it. Shouldn't be any errors since we are only changing one number. Let's go to program. Okay, and now we're going to check it. Okay, so this is a trial with the confidence levels at 500. Let's see if we get any bouncing going on here. It looks pretty good. I'll do it for a pretty good amount of time here. It looks like we've pretty much taken care of the bounce, and we don't have any bouncing. We are sampling 500 ones and 500 zeros. That should be enough to omit any sporadic bouncing, so it looks like it's working quite well. And I'm going to leave it at that. I'm going to keep it at 500. The next video we're going to actually create a game, and we're going to have a bunch of LEDs, probably 7 or 8 LEDs on one side and 7 LEDs on the other side, 2 buttons, and it's a sort of a contest on how many who can get to the top of the LEDs faster by pressing the button as fast as they can.